All right, I'm going to share my screen to talk about properties of logarithms. And this is section 5.5. So basically, I'm going to show you in this section how to apply basic properties of logarithms, and we're going to use those properties to expand and combine logarithmic expressions. And then we're also going to cover the change of base formula, which I already introduced in a previous section, but I'm going to just remind you of that formula in another video. All right, so if you consider the fact that logarithms are exponents, it makes sense that if you're looking for the exponent on your base A that will give you an output of 1, of course, that exponent would be 0 because any number to the power of 0 is always 1. So this formula follows from that property. And so the log base A, it doesn't matter what the base is, if it's a valid logarithmic base and you're evaluating at 1, you get 0. And that means that the point 1, 0 lies on the graph of all basic logarithmic functions. Okay, this property here says that log base A of A is always going to equal 1. And that's simply because the exponent on A that gives you A is going to be 1. A to the power of 1 equals A. So that's where this property comes from. Now, the fact that when you are when you're multiplying exponents, so if you take a to the n power and multiply it by a to the n, remember you add the exponents, that property results in this logarithmic rule. It's called the product rule, that if you have two logs with the same base that are added together, then that's the same as taking the log of the product. So the log of the product is the sum of the logs, is how I would say that. Or the sum of the logs is the log of the product. Okay, that's called the product rule. The quotient rule is similar to that. Just remember that when you have a negative exponent, that throws things down into the denominator. We don't have to go into a formal proof of this, but if you take the difference of logs, that's the log of the quotient. And it relies on the fact that you have the same base. You can only do this property or use this property if the bases are identical as they are here. The power rule just says that you can, when you're taking the log of something raised to a power, you can multiply that power out front, okay? So these rules are used to do what we call expand a logarithm or combine a logarithm. So in expanding and combining is another word used is condense. They're used pretty much interchangeably. I really don't distinguish between combining and condensing, but they use both terms in this textbook. So when you're expanding, you're taking here you have the log of a product. You're expanding it from 1 log into 2 logs. So you can separate the product, the factors, and take the log of 10 plus the log of A. That's the same as the log of 10 times A. And the log of x divided by 5, for example, is the log of x minus the log of 5. And the log of x cubed equals 3 times the log of x. So when you go this way, when you start with the ones on the left and end up with the ones on the right, you're expanding. If you start with the ones on the right and end up with ones on the left, that's combining or condensing. Okay, so we'll be doing some examples in a future video. So here are some examples. You're expanding. So you can see that we start with 2x to the 4th, and that becomes 1 plus 4 log 2x. And I'm going to show you in the next video how we do these problems.